pre-algebra. This was requested by Mr. Mike Atkins, and I've told you before, if you guys want to learn, I want to do whatever I can to help you learn. He requested a video lesson. I hope he watches it. I'm very proud of him for asking, and I wasn't planning on doing this, but because he asked, I don't want to tell him no. I want him to be successful. I want you all to be successful. All right, enough talk. Let's get right into it. Let's say our first pattern of numbers goes like this: 2, 9, 16, 23, and 30. All right, well, I'm going to make my little table, and let me see here. All right, shoot, 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 shoot. Little sound effects for your entertainment. 1, 2, 3, 4, 5. Oh, look at that. I can't believe how fast I am. Okay, now let me see. Did that work? That almost worked. Okay, no problem. I will infinitely clone that. Boom. All right, very good. Remember, the first thing I always do is I try to find my first level of differences. If they're all the same, that's great. That tells me an important thing. If they're not the same, I might go to the second level. I might look for something else. But let's see here. How do I turn 2 into 7? Oh, I have to, excuse me, 2 into 9. I have to add 7. How do I turn 9 into 16? I have to add 7. How do I turn 16 into 23? I have to add 7. It's add 7 every time. By the way, if you're not sure how I got that, take 30 and subtract 23 from it. Not 23 minus 30, 30 minus 23. 30 minus 23. And you will get 7. 23 minus 16 is 7. 16 minus 9 is 7. So you could subtract to figure that out. All right, now in each case, I am adding 7 on the first difference. That means my answer will be something like 7n. Now, I have to do my comparison line. 1, 2, 3, 4, 5. I take these black numbers here, the 1, the 2, the 3, the 4, the 5, and I plug them in for n. 7's being multiplied by n, so this line will be 7 times 1, which is 7. This second line will be 7 times 2, which is 14. The third line, 7 times 3, 21. I'm showing a little more detail than I have before, just in case there's somebody who's confused. 7 times 4, that is 28. 7 times 5, that is 35. Now, I do my comparisons. Now, by the way, these are kind of in my way, so I'm just going to move them out of the way. And I'm going to compare. I always compare up, right? Always compare up. How do I turn 7 into 2? I add 5. How do I turn 14 into 9? Oh my goodness, Mr. Lawrence, silly mistake. I always compare up. Turning 7 into 2 is not comparing 5, adding 5. It's subtracting 5. 14 turning into 9, that's subtracting 5. 21 into 16, that's subtracting 5. I subtract 5 every time. So my answer, my 7n, I have to subtract 5 from it. So it'll be 7n minus 5. And there we go. It's that simple. Oh, excuse me. All right, let's look at our next pattern. Our next pattern will be like this. Let's see here. 6, 2, negative 2, negative 6, negative 10. Remember, I need to make my little table, which is almost done. By the way, did I mention I like my smartboard? I don't like it. I love my smartboard. Okay, very good. I might want to scooch that 6 over. No, that's going to move everything. I'll just rewrite him. Okay. Again, I'm going to find my first differences. I'll tell you what. If you think you're really good at this, go ahead and pause. And then see if you can come up with the nth pattern on your own, and then I will go ahead and you can unpause and you'll see my work. All right, so pause now, and then unpause when you're ready. All right, I'm going to minus 4, I'm going to minus 4, I'm going to minus 4. That means my formula must be something like minus 4n. Compare lines. I will do negative 4 times 1, negative 4, negative 4 times 2, negative 8, negative 4 times 3, negative 12, negative 16, negative 20. All right, I will compare up now. How do I turn negative 4 into 6? negative 8 into 2, negative 12 into negative 2. Oh, that one's add 10. Let me check this out. Negative 8 plus 10. Yep, that's positive 2. Negative 4 plus 10, that's positive 6. So I must have to add 10 to my negative 4n. So my nth term is negative 4n plus 10. Hopefully you got it right. If you did, go ahead and feel free to pat yourself on the back. All right, let's look at another example. I'm trying to keep this video quick, so I'm talking fast. You can always slow me down, rewind me, whatever you need to do so that you can understand what's going on. I'm so excited that some of you want me to flip the classroom. Pattern number 3, negative 5, negative 2, 3, 10, 19. Now this one's just a wee bit different. Okay. It's different because, there we go. I'm going to do my first differences just like I did in all of them. Looks like I'm going to add 3. Oh no. Now I'm going to add 5. Uh-oh, I don't like this. Danger, Will Robinson. Add 7. Add 9. It's not the same amount. I'm going to panic. Oh no. Actually, no, I'm not. I'm just going to look down another level. Plus 2, and plus 2. The second level matches. You might remember from class when the second level matches, that means the pattern is some type of n squared. Okay? If I went down to the third level and it matched, that would be n cubed. If I went down to the fourth level and it matched, it would be n to the fourth. Now remember, matching doesn't mean I just run out of numbers and there's only one number left. I have to get a repetition. On the second level, I got plus 2, plus 2, plus 2, plus 2, and plus 2. Okay, I'm going to do my comparison line, and to get some of my work out of the way, because it's a little annoying when you're trying to compare, I'm just going to move these off to the side, and then I'm going to get rid of these because it looks like subtraction sign. And I'm going to square these black numbers, 1, 2, 3, 4, and 5. Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Now, many of you wanted to write down 2, 4, 6, 8, 10. You're not thinking. Square does not mean times. It means the number multiplied by itself. It's not 1 times 2. It's not 3 times 2. It's 3 times 3 right here, because it's squared. N squared means 3 times 3. 4 squared means 4 times 4, which is not 8. Now again, you're allowed to use your calculator, so there's no reason to get that wrong. All right, I'm going to compare up. How do I turn 1 into negative 5, 4 into negative 2, 9 into 3, 16 into 10? Hey, 16 minus 6 is 10. 9 minus 3 is, 9 minus 6 is 3. And 4 minus 6 is negative 2. It looks like I'm going to subtract 2 from every term. So if my nth one had to be something like n squared, and then I have to subtract 6 from it. Okay? Do me a favor. If you're a person who gets the n squared pattern wrong, just write down n squared, okay? And then n, and let's do 1, 2, 3, 4, and 5. Okay, now this is only for people who are having trouble with the n squared part or n cubed per se. If you're getting it wrong, go ahead and see if you can fill this out. Pause the video and see if you can fill out this table correctly. All right, and if you don't need to, then just kind of let this part of the video go, and you can move on to the next part. Okay, so go ahead and pause if you're a person that needs to practice this. If you don't, go ahead and let it run until the next part. Okay, once n squared is 1, n cubed is also 1. Why? Because this means 1 times 1, which is 1. This one means 1 times 1 times 1, which is also 1. 2 to the second power, that's 4. 2 to the third power is 8. Why? Because it's 2 times 2 times 2. All right, 3 squared is 9. 3 cubed is 27. All right, 4 squared, 16. 4 to the third, 64. 5 squared is 25. And 5 cubed is 125. All right, that was just a little practice to help you get it right. Remember, you're allowed to use your calculator, so no reason to get that part wrong. Okay, let me see here. We need one more pattern, and you can probably guess this is going to be an exponential one. We go -1, 5, 23, 77, and 239. Again, I'll make my table. This will be N, 5, 4, 3, 2, 1, blast off. Okay, I start in the same way. Now, if I was Mike Atkins, when I was helping Mike Monday in class, he kept going, man, those are getting big quick. If they're getting big really quick, that's a hint that it's probably some type of like 2 to the power n, 3 to the power n, something like that. It doesn't guarantee it, but it probably is. All right, let's go with our first differences. Let's see, that's going to be a +6, I believe. -1 plus 6 is 5. That is going to be a +18. Okay, that, let me see, 77, 23. It looks like I'm going to get a 54. Okay. All right, let me see, 77, 239 minus 77. It's going to end in a 2, and then that's going to be 162. Now, you may not see it yet, but watch this. I see something right now. I got a warning bell going off, but watch this in case you don't. All right, +12, +36, and let me see. That one would be, I have a mental blank, pardon me, showing my work. Okay, there's an 8, 15, 108. Okay, I'm going to notice here that 6 times 3 is 18. Hey, 12 times 3 is 36, isn't it? You know what I'm going to do? I'm going to divide 54 divided by 18 on a calculator. Oops, it's 3. That means that times 3. See how that times 3 keeps showing up every time? Guess and check on a calculator. 54 times 3, you betcha, 162. I'm multiplying by 3 every time. If I multiply by 3 every time, my answer is going to be something like 3 to the power n. I need to do my comparison line. Let me repeat that. If I multiply by 2 every time, my answer is going to have a 2 to the power n in it. If I multiply by 3 every time, it's going to be a 3 to the power n. If I multiply by 7 every time, it's going to be a 7 to the power n. Okay, now I'm going to do my comparison line, and again, I'm going to get rid of this work because it's in the way. You won't ever erase work. You know, you can rewrite part of the problem if you want on another part of the paper or something, but never erase work. Okay, so 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. 3 to the fourth power is 81. 3 to the fifth power is 243. And I'm going to compare up. How do I turn 3 into -1? How do I turn 9 into 5? 27 to 23, etc., etc. Well, I know 27 minus 4 is 23. 9 minus 4 is 5. I also know that 81 minus 4 is 77. If I check 3 of them, I'll be right on like 98% of them. It's only a rare time I have to go 4 or 5. But you can check them. It will end up being -4 in every single one. I take my 3 to the power n, and I subtract 4 from it. Okay, guys, that is the review video. Hopefully it helps you do well on the test. Mr. Underhill and I would love to see you excel on tomorrow's test. All right, Mr. Lawrence signing off. Au revoir.